Welcome back. Again, I'm Josh, and I'm continuing the sensor tutorial here at Urban Workshop using the Tinkercad platform, so all of you at home can follow along. Now, I was going to run you through how to do this sensor right here. This is the this is the water sensor, but when I went to search on the platform, I actually couldn't find it. So it doesn't look like we can replicate the water sensor side of things on Tinkercad. So I think I'm going to go ahead and use the temperature sensor. So if you type in temperature into this box in the upper right hand corner here, you should find this little sensor here. And it looks like it tells me power, V out, and ground. That's extremely useful. When I highlight my cursor over it, I know what my signal is because V out is the actual voltage out. It's the signal that it's going to transmit. The power is going to be plugged into the 5-volt power rail, and the G and D, just as usual, is going to be grounded. So let's go ahead and rotate this a couple times, pop it into my board here, maybe on that edge there. This is power, so let's go ahead and run that to 5V, change that color to red, good to go. This is G and D, so we got a G and D right there, change that to black, perfect. And we'll plug this into analog pin 0. Remember, analog pin 0 is going to allow us to get a range of values from this temperature sensor. And because we're sensing temperature, which is a range, it might be 75 degrees, it might be 35 degrees, depending on where you're viewing this tutorial from right now. So I'm using the analog pin so that I can tell with some degree of accuracy what my temperature is. So analog pin 0 over here. What happens if I go to code? What's pre-written? Anything? So I've got some pre-written code up here on the screen, but it's actually for an LED plugged into pin 13. That is not the code I want. So what I'm going to do is I'm going to take a minute to search the interwebs for this particular TMP 36. What is it? The TMP 36 temperature sensor. I'm going to go ahead and search online to see how we program this thing, and I will see you in just a minute. All right, welcome back. I have found some reference code here, and I'm going to go ahead and test out writing it. So up here in the code block, you're going to go ahead and press the code in the top right. You get this drop-down menu, and let's just go ahead and delete everything inside of the void loop. I'm not going to delete that open and close curly brace. I'm going to delete everything inside of void setup. I'm going to go ahead just above setup and type int sensor pin with a capital P equals 0. Now this is called camel case, where we capitalize the first letter of the second word. So int sensor pin with a capital P equals 0. Inside of void setup, I'm just going to go ahead and leave that blank for now, but I do need to keep the void setup or our program will not run. Now inside of void loop, I'm going to type int reading equals analog read sensor pin. Now this is creating a variable called reading. We are going to use the function built into Arduino called analog read, and we will read what is happening inside of, I typed sensor read pin, inside of the sensor pin, which is analog pin 0 right here, which is where we're plugged in on our Arduino board. Now this is where we're going to be reading that voltage output and doing some conversions and actually figuring out what the temperature is. So analog read is a function that just allows us to read what's happening inside of that pin. Floating point integer, float voltage reading times 5. I'm not entirely sure what's happening here just yet. I'm kind of thinking this through, maybe with you. I'm going to go ahead and tab that. Space. There we go. 2 spaces. Voltage, perfect. Voltage minus equal 1024.0. Floating point integer, temperature C, which stands for Celsius. see. Sorry, a little clunky. As I said, I haven't actually done this before. This is the first time I've done this. And so I am learning right alongside all of you about what all of this means right now. Okay, so it looks like we're going to have some sort of Celsius temperature here. That is voltage minus 0.5 times 100 fine temperature F equals temperature C, Celsius temperature times 9 divided by 5, 0 by 5.0. So that's 9/5 plus 32, converting Celsius and Fahrenheit. You may remember that from math class at some point. And go ahead and give it a 1 second delay, or 1,000 milliseconds. Now what's happening here? I've got some variables. What I don't know about how all this works is where I actually read these output values. I guess we're about to figure that out right now. I may actually need, whoops. That's okay. This needs a semicolon at the end. But take a minute to make sure, if you need to pause the video and verify that your code is correct based on the code that I've written here, do that now. What happens if I press start simulation? It plugs it in, and I can't tell. 25 degrees Celsius. Oh, we want to read this in the serial monitor. Let's see if we can use the serial monitor to read some values here. I don't actually know. Okay, so stop your simulation. Inside of void setup, let's try this. See what happens. Double space here. Serial dot begin 9600. This, I'm hoping this is a way for us to be able to read some values to see the serial monitor, though I don't have any idea if this is going to work here. Okay, below this, the float temperature, we're going to go ahead and write below serial.println. Let's just print temperature F. That'll work for us. And then serial.print. Let's just do serial.print temperature F, and serial.println is going to be degrees. I don't know if this will work. I don't know what's about to happen. Let's try it. I don't see anything related to a serial monitor. Oh, here it is. What is this? Oh, look at that. Okay, so it's telling me our serial monitor is here. So I've just gotten our entire serial monitor to work. I know this code works, and I know it's wired correctly. So again, if you're confused, if yours isn't working at this point, pause the video, make sure you've written the text exactly as I've written it here, and that you've wired this thing up in exactly the same way that I've wired mine up. Now it's telling me it is 76.47 degrees, and it's doing it every second. I think I can click this. Oh, look at that, 20, it's in Celsius. So if I turn it up, look at that, our temperature goes up. I'm turning it up. Ooh, it's getting pretty hot. We're getting closer to oven temperatures here. 160 is an oven temperature. So you should see in your serial monitor, down here in the bottom, a reflection of the Fahrenheit temperature based on whatever the Celsius temperature is that we've dialed it up to. Now, typically you'd have this sensor in a room, and you'd want to know the temperature of the room, or you'd have it in an oven, and you'd want to know the temperature of the oven. And then you'd want to do something. Hey, when it's above 150 degrees, turn a light on. When it's above 250 degrees, turn the whole thing off, turn the machine off, turn the motor off. You know, you're kind of doing something in response to it here. So
Play around with that temperature sensor and see if you can't get something like an LED to turn on or off depending on how high that temperature is. I hope you enjoyed this tutorial. There's plenty more that we could do with both the temperature sensor and the original photo resistor or the light dependent resistor that we used in that first tutorial that you may have seen just a moment ago. There's plenty more that we could do with these. We'd really want to control other components and do more stuff. I'm going to stop there for the day because I think that's enough information for us. I hope you enjoyed this tutorial on Tinkercad, and let me know in the comment section what else would be useful for you. All right, thanks so much.